Alright, welcome to this week's study guide. Let's start off with systems of equations and solving systems of equations by graphing. So when we're solving systems of equations by graphing, we want to graph both lines and see where they intersect or where they cross, and that would be your solution. So for number one, if you notice, both of those equations are in standard form, ax plus by equals c. They are not in slope-intercept form. So what we'd want to do first is change them to slope-intercept form. And I'll do the first one in red. So that's 3x plus y equals 5. Remember, when you're changing it to slope-intercept form, you're trying to get y by itself. Slope-intercept form is y equals mx plus b. So you first want to get rid of that 3x by doing the inverse operation or by subtracting 3x on both sides. And that would cancel the 3x out on the left-hand side, and it would leave us with just y. And we have negative 3x plus 5. It would be in slope-intercept form, which is y equals mx plus b. I'll do the next one in blue. We have x minus 4y equals 32. So again, we want to get rid of the x first. And that would leave us with negative 4y equals negative x plus 32. Then we'd want to divide both sides by negative 4 in order to get the y completely by itself. And if we do that, the y's would cancel out, and we'd be left with y equals, these two negatives are going to cancel out as well. So that would be positive 1/4 x. And then 32 divided by negative 4 would be a negative 8. And now we would graph them. So remember, when you're solving systems of equations by graphing, you want to make your graphs as neat and as straight as possible in order to find where they intersect. Okay? Now, the first one has a y-intercept of 5. So that would be the first thing you put on your graph. And then it looks like it has a slope of negative 3, which would mean that we'd go down 3 to the right 1, 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 down 3 to the right 1. Or we could go up 3 and to the left 1. And you draw your line as straight as possible, and that would be your first one. Now the next one I'll do in blue, and that one is has a y-intercept of negative 8. Should be right here. And then our slope is 1/4, which would mean we go up 1 to the right 4. And you could already kind of figure what the solution is going to be just by that first point. You could also go down and to the left 4. And draw your line as straight as possible. So what would the solution be? It's going to be this point right here, which, if we look at our coordinate plane, that point is at positive 4, comma, negative 7. So the solution is going to be 4, comma, negative 7. And that would be the solution to your first systems of equations. Let's take a look at number 2. Number 2, the first equation is already in slope-intercept form, which is y equals x plus 4. And I'll do that one in red. Y equals x plus 4. The next one is x minus y equals 1. So we'd have to subtract both sides by x. And I'm going to do this a little quicker now because the steps to changing equations to slope-intercept form is something that we've already studied. And it's something that I slowed down a bit in the previous example, so you could always rewind and go back to the previous example if you want more detailed steps on how to change an equation to slope-intercept form. So, oh, I didn't mean to do both of them in red. I'm sorry. I'll just change. This one was supposed to be in blue, which is this was my second equation. I got carried away. So what do you notice between your first and your second equation? Well, what I notice is that the slope is the same, but the y-intercept is different. And if you remember from the transformation section a couple weeks ago, that would mean that we're going to have parallel lines. So without even graphing it, I know that there's not going to be a solution. But let's go ahead and graph them nonetheless. So the first one, the red one, is going to have a y-intercept of 4, and then we are going to go up one to the right one, up one to the right one. It's a slope of 1. And then draw as straight of a line as possible. And then the next equation, the one that I'm going to do in blue, is going to have a y-intercept of -1. We're going to go up one to the right one, up one to the right one. And if you notice, those are parallel lines. When we have parallel lines, we do not have a solution. There would be no solution. Now, for your test tomorrow, these are the only two. Oh, no, these aren't the only two system of equation problems, so disregard what I was about to say. Let's talk about this one. X equals -2. That we don't need to do anything to, and I'll do that one in blue since I already circled it in blue. X equals -2 means we're going to have a vertical line on -2. And that is from a few modules ago. You should know that anytime we have x equals a number, that's going to be a vertical line. And then 3x minus 2y equals -18. First, you're going to change this to slope-intercept form. And again, I'm going to do this a bit more rapidly than I did the first problem because you should by now know how to change equations from standard form to slope-intercept form with ease. But if you don't, look back on number 1 where I went through it a little bit slower. So that would be y equals, these two negatives will cancel out. That would be 3/2 x. Then -18 divided by -2 would be +9. Okay, so 9 is right here. And our slope is 3/2. So we'd go up 3 to the right 2, or we go down 3 and to the left 2. And that right there would already give you your answer, which is going to be, it looks like it's -2, comma 6. That's it. That's your solution. That's where they intersect. Over here we have y equals a number, and I'll do that one in, let me change the colors up. I'll do green this time. So y equals -7 means we're going to have a horizontal line at -7, which is right here. But the top equation, which I'll do in yellow just to switch the colors up a bit, is not in slope-intercept form. That is in standard form, so we would have to change it to slope-intercept form. Subtract x first, you'd get 3y equals -x minus 15. Then you would divide both sides by 3, and that would give you y equals -1/3 x minus 5. So our y-intercept for this next equation is going to be -5. And then from there, it looks like we're going to go down 1 to the right 3, down 1 to the right 3, down 1 to the right 3, which would already give us our solution even before we draw our line. And our solution is going to be this point right here, which is 6 and -7. 6, -7 would be your solution. All right, if a system of equations only has one solution, then that means both lines intersect. So the lines intersect. What does it mean if we have no solutions? So remember, if we have no solutions, that would mean that our two lines are parallel, which we had an example of like that with number 2. So that means the lines are parallel. And what about if there are an infinite amount of solutions? That would mean that we have overlapping lines, okay? And if we have those aren't exactly overlapping, but they're supposed to be right on top of each other, it means that we have the same line. So if we have the same line, that means we would have an infinite amount of solutions. So graphing inequalities. Remember, graphing inequalities, if we have a less than or a greater than symbol, that means our line is going to be dotted or dashed, okay? if we have a greater than or equal to and a less than or equal to symbol, that means our line is going to be solid, okay? If we have a less than or equal to sign, that means we're going to shade below the line. If we have a greater than or equal to sign, that means we're going to shade above the line. And our first step is always getting into slope-intercept form. Luckily, number 8's already in slope-intercept form. So we'll graph it. Our slope is 1. Our y-intercept is 1. And our slope is -2, so we go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. Or we can go up 2 and to the left 1, up 2 and to the left 1, okay? Now, what kind of line is this going to be? Is this going to be a solid or a dotted line? This right here is what determines whether it's going to be solid or dotted. It's less than or equal to, so that would mean that it's going to be a solid line. Just like that. Now, this is an inequality, so because this is an inequality, we're going to have to shade either below or above this line. It's less than, so less than is going to mean that we're shading below the line. And that would mean that anything in the shaded area, including the line, because the line is solid, would be a solution to this inequality. Number 9. Number 9 is in standard form, so we'd first have to change this to slope-intercept form. So let's do that quickly. The first thing we'd want to do is subtract 2x on both sides. Zoom in here. Subtract 2x on both sides. And if we do that, we end up with -5y is less than -2x plus 20. What we would do next is divide both sides by a negative, but when dealing with inequalities, remember, if you divide both sides of an inequality by a negative, you have to flip the inequality symbol. These two negatives will cancel out, which would make a 2/5 x, and then 20 divided by -5 would be -4. And that's the inequality in slope-intercept form. So first we would graph the y-intercept, which is -4, which is right here. And then we would go up 2 and to the right 5, which is going to be right here. And we draw our line. Oops, I messed up. I'm sorry. So we would not draw our line. We would look at our inequalities symbol here, and it is a greater than symbol, not a greater than or equal to symbol, so that should not have been a solid line. It should be a dashed line or a dotted line, and that means that we are not including the line in our solution. We are not including the line in our solution, and it is y is greater than 2/5 x minus 4, so that is going to mean that we are going to shade above the line this time, which is going to be this area over here. And that's going to be our solution to this problem. And last but not least, number 10. Again, we'll have to change number 10 to slope-intercept form first. So we'd subtract both sides by x. We do that, we get -3y is less than -x. Then we divide both sides by -3. Because we divided both sides by -3, we have to flip the inequality symbol. These two negatives will turn into a positive, and that will turn into 1/3 x. So it looks like our y-intercept is going to be at exactly 0, and we're going to go up 1 to the right 3. Or we could go down 1 to the left 3 as well. Now, looking at our inequality symbol, it's just a greater than symbol. So again, we're going to have a dashed line or dotted line, which just means that we are not including the line in our solution set. It's greater than, so that means we have to shade above the line. This time I'll use green. So we're shading above the line. That is your solution for number 10. Number 11. Which ordered pair is a solution to the inequality below? So if you get a problem like number 11, just first graph this inequality on the coordinate plane. You know how to do that. You'd subtract by 3x first. Then you get -5y is greater than or equal to -3x plus 10. We'd have to divide both sides by -5. And remember, when you divide both sides of an inequality by a negative, you have to flip the inequality symbol. So that would be y is less than or equal to positive, because these will change to positive, 3/5 x. And then -2, 10 divided by -5 is -2. You graph this on your coordinate plane. You have -2 right here, And it looks like we're going to go up 3 and to the right 5. Or we could go down 3 and to the left 5. What kind of line is this going to be? This is going to be a solid line because it's less than or equal to. And we're going to shade the bottom because it's a less than or equal to symbol. And anytime we have a less than or equal to symbol, we're going to shade the bottom. Now, how would you solve this type of problem? Well, you should know how to do that, hopefully. What you would do is you just look at all these ordered pairs and see which one is actually in the shaded region, or in this case, it could be part of the line as well. So 1, 4 is definitely not going to be our answer. That's over here. Let me use a different color. That's over here. So that's not going to be one of the possible solutions. 6, -3, that looks like it will probably be our answer. 6, -3 is going to be right here. Okay, so that right there is going to be your answer. -5, -2. If you plot that one, you'll see that that one's going to be over here, which is not part of our solution. And 2, 0, very close, but not part of our solution set. So the only one that's in that shaded area would be 6, -3. In the last one, we have x plus 4y is less than 4. So first you'd have to subtract both sides by x. You'd be left with 4y is less than -x plus 4. Then you divide both sides by 4. No need to flip the inequality symbol this time because you are not dividing by a negative number. That would just be -1/4 x plus 1. So your y-intercept would be 1, which is right here. And your slope is -1/4, so you'd go down 1 to the right 4. Down 1 and to the right 4. Just like that. Or you go up 1 and to the left 4, up 1 and to the left 4. This is going to be a dash or dotted line because it's a less than symbol, which means that we're not including the line in our solution set. So if we did happen to get an ordered pair that was right on the line, it would not be part of the solution. And it's a less than symbol, which means that we are going to shade beneath the line for this area right here. Oops, I went a little over. This area right here would be our solution set. Now let's see which ordered pair here satisfies this inequality. -3, 5 doesn't look like it's going to work. -3, 5 would be right here. So that's not part of our solution. 0, 4 also doesn't look like it's going to work. That would be right here. 2, 3 also doesn't look like it's going to work. That's going to be right here. And -8, -2. That is going to work. That's in that shaded area. I know I did a horrible job shading this, but that's supposed to be shaded too. That's below the line. Okay, -8, -2 is in that shaded region. So that is going to be the solution of this. That's going to be one of the solutions of this linear inequality. So your answer would be D. And that's it. Your test is only going to be on graphing linear inequalities and on solving systems of equations by graphing. Good luck. Make sure you study your notes tonight. Good luck on your test tomorrow. I will see you tomorrow.